Hey everyone, DigiDecode here. Today I want to talk about this really fascinating new AI research paper from UC Berkeley, Microsoft Research. It's called Gorilla. As AI and machine learning have advanced rapidly in recent years, large language models like GPT-3 have shown they can do some really impressive things like holding natural conversations and even generating code. But one area they still struggle with is accurately using tools and API, which are essential for connecting these AI systems to real-world applications. The researchers behind Gorilla have proposed a new approach to train large language models to effectively utilize potentially millions of tools and API functions expressed in code. Their key innovation is combining self-instruct fine-tuning of the language model with document retrieval of up-to-date API documentation. They constructed a comprehensive dataset of over 11,000 examples mapping natural language instructions to code snippets using API from major machine learning model hubs like PyTorch, TensorFlow, and Hugging Face. This dataset was used to fine-tune an existing 7 billion parameter language model called Llama. The resulting fine-tuned model, Gorilla, significantly outperformed GPT-4 in accurately producing valid API calls from natural language prompts. It also showed the ability to adapt to changes in the API documentation at test time when using the document retriever. For example, if an API was updated to use a newer version of a library, Gorilla could leverage the updated documentation provided by the retriever to generate the correct new API call. This is a really important capability as API change all the time. The researchers demonstrated Gorilla could understand API constraints around things like model size and accuracy as well. This research illustrates how connecting large language models to changing external knowledge can make their capabilities much more robust and useful for real applications. Being able to accurately map natural language to API calls opens up so many possibilities for using these powerful AI models to accomplish complex tasks. The Gorilla paper shows promising progress towards enabling any user to simply describe what they want to an AI assistant, and have it figure out how to leverage the right tools and API behind the scenes to actually make it happen. The researchers introduced several innovative techniques that enabled the advances demonstrated by Gorilla. A central method was self-instruct fine-tuning, where they synthesized a large dataset of instruction API example pairs from API documentation to specialize the base Llama model on generating API calls. They also proposed retrieval-aware training, where examples include a relevant API documentation snippet. This helped improve results and adaptability. For evaluation, they introduced AST subtree matching to effectively check if a generated API call matched the ground truth API based on arguments. The researchers did an extensive set of benchmarks to evaluate how well Gorilla performed compared to other state-of-the-art AI models. They tested Gorilla along with models like GPT-3, GPT-4, Claude, and Llama on generating the correct API call across 3 large code datasets they compiled. For the Torch Hub dataset, Gorilla achieved 59.13% accuracy in selecting the right API call compared to only 38.7% for GPT-4 in the zero-shot setting. On the Hugging Face dataset, Gorilla obtained 71.68% accuracy versus 19.8% for GPT-4. And for TensorFlow Hub, Gorilla reached 83.79% accuracy, far exceeding GPT-4 at 18.2%. The benchmarks also analyzed important factors like avoiding hallucination errors and handling constraints. Across the board, Gorilla outperformed previous state-of-the-art models. The comprehensive API bench dataset and evaluation framework developed alongside Gorilla will really push forward research in this area. But these initial results demonstrate a significant leap in capabilities. So getting back to explaining this Gorilla paper, the researchers found it was really challenging to properly evaluate how well different AI models could generate valid API calls. Unlike a typical machine learning task, there isn't one right answer for selecting an API. There are often many different API on something like Hugging Face that have overlapping functionality and nuanced trade-offs. To address this evaluation challenge, they came up with a clever technique using AST subtree matching to effectively check if a model's generated API call matched the reference API from the dataset. Using this evaluation approach, they showed Gorilla significantly exceeded the performance of top existing models like GPT-3 and GPT-4 on producing correct API calls across the 3 major code datasets they tested. The paper also analyzed different ways of integrating retrieval into the training and inference process. They found fine-tuning Gorilla with an Oracle retriever improved results, demonstrating the potential for better retrievers in the future. To illustrate how Gorilla is able to generate an appropriate API call from a natural language prompt. Say we wanted an API to perform speech recognition to transcribe audio of someone speaking into text. We could give Gorilla a prompt like, "Help me find an API to convert the spoken language in a recorded audio file to text using TorchHub." Given just this natural language description, Gorilla would return the API call. This shows how Gorilla is able to take a high-level goal described in everyday language and map it accurately to the right API call to load the Silero SST speech recognition model from TorchHub to transcribe the audio. The researchers have open-sourced Gorilla and the evaluation datasets to help advance research in this exciting area of connecting language models to real-world API. As exciting as this research is, there are still some limitations in the current work that are important to discuss. One aspect is that the focus was exclusively on API calls for machine learning models. Expanding this approach more broadly to API in other domains would be an important next step. The dataset, while large in terms of number of API covered, still has limitations in terms of diversity. Testing Gorilla on a wider range of unseen API would better evaluate generalization. There is also room to improve the sophistication of the constraint reasoning demonstrated. Gorilla showed basic capabilities, but more complex constraints need to be explored. Finally, while retrieving documentation helps, there are still risks of the model hallucinating or misusing an API if the documentation itself has errors or omissions. So in summary, Gorilla makes promising progress, but there is definitely more work needed to expand the scope, robustness, and safety if this is going to be deployed in real-world applications. Research like this highlights the challenging nuances around effectively utilizing API in the open world. But I'm optimistic continued advances in self-supervision, retrieval, and constraint modeling will make this possible.